Hi, this is Will Durfee, and I'm going to show you how to create gears using Creo that can be later 3D printed. And some of the websites I'm going to be using in this tutorial are listed on this title slide. The first thing you need to do is to create the shape of the gear. And it's nice to be able to create an involute tooth shape. There's a number of online gear designers that can output DXF files that can go to the laser cutter, or as I'll show you, can be imported into Creo to make a three-dimensional gear. So I'm going to be using this one called Gear Designer, but you can find a number of these on the web. So the modulus has to do with the size of the gear tooth. And I'm going to go with a modulus 2 size tooth. And you can look up online to see what modulus means. And then I'm going to do a gear with a 24 teeth to it. And then I'm going to put the hole in the middle of 4 millimeters, which matches the hole size for a number of different motors. And you can do spur gears, you can do internal gears, you can do rack and pinions. So we're going to do spur gears, and let's just zoom in a little bit so we can see our gear. And then, because I only want to do one gear, I'm going to set this second one to be 0 teeth, which makes that gear disappear. Okay, so now my gear shape is all set, and I can save it to a file, and it's saved as a DXF file. And I just noticed that the second gear still has the hole in it, and so let me change the hole diameter to 0 on that second gear. Now that second gear completely goes away, and then I'll resave it to the file, and then I'm going to go ahead and rename that gear.dxf. So if you want, you can take a look at your DXF file. In this case, I'm using the application eDrawings and opened up that file, now renamed to gear.dxf, and it looks pretty good, and you can see the involute tooth shape. If you go ahead and measure the diameter of the hole, you'll see that it's diameter 4 inches. That's because it doesn't yet know that this was, that we're thinking about millimeters rather than inches. So when we go to Creo, we'll have to change the default units to millimeters. Okay, now we're in Creo, so the first thing we're going to do is to set the working directory. So let's go ahead and find, I've got that file in a directory called Gear Demo, so I'll set that to be the working directory. And then you can see that gear.dxf in the file. Okay, so we're going to go ahead and open and look for DXF files, and then the gear appears. So we'll click on that and then import. So the import new model, there's a couple things we want to do. First, we want to import as a part, and then you want to go under details of the current profiles, and under the curve tab, import as a set of curves. And click OK on the import, and then just check that the import type is curve, and then click OK. Okay, and you can see, well, let's click on it. We can see now the shape is imported into Creo. So now we're going to want to extrude that. And to extrude it, we first have to define a plane that's in the same plane as this shape to extrude from. So we go up under Model, and then Datum, and click the plane. And then it's asking where to place it, so just click on any part of that gear shape that you've imported, and that'll put down a plane that's in the same plane as the gear shape. So now we click OK. So next, we're going to extrude. So go to Model, Extrude. The plane is already selected. Well, here we can select the plane, and then Extrude. And now we're in the sketcher and extruding on the plane of the gear. Now under the sketching tool, we go to the project tool, and then there's a little dialog that pops up for type, and we want to select type as loop. and then it's asking us to select entities in the loop. So just go in and click on any part of that curve of the gear, and then click on the hole, and then hit close for the type, and then you can click OK for the sketcher. And now that puts us back into the extrude dialog, and then we can pick the thickness of the gear, which in this case we'll make to be 10 millimeters thick. Click OK, and there is our gear all set to go. Now the one thing I haven't done is to change the units to millimeters, so let's go in and do that. So under File, Prepare, Model Properties, and then under Units, the default is set up as inches, so we want to change that. And in the Units Manager, change it to millimeters. So set. And then it's asking us, changing the model units, we want to interpret dimensions so that the 1 inch becomes 1 millimeter, and then uncheck the convert the absolute accuracy value. So we'll click OK there and close the units, and now we're interpreting in millimeters. And then just to check that things are okay size-wise, we can go into Analysis, click on the measuring tool, measure distance, and then we'll go from a point on one side, press down the control key, point on the other side, and this gear 43, 44-ish millimeters across, so it's the right size of the gear. So you could go ahead and export this as an STL file to bring it over to your 3D printing software. But let's say we wanted to add a hub to the gear to give a little bit more surface area for the motor shaft to grab onto. So let's go ahead and add a hub. So for that, I'll do Model, then we'll do Extrude, and then we want to pick the surface of the gear as what to extrude from. And then we're in the sketcher, so we'll go to Setup, and that takes us looking straight down on the gear. And we're going to go ahead and do a hub, which is basically a cylinder with a hole in it that's centered around the whole of the gear. So let's start with a circle that is a 3-point circle, and then we'll pick 3 points on the surface of the center hole, because it doesn't yet have the center of that center hole as a dating feature. So we'll click again there, and then click again there, and that gives us a circle that is sits right on top of the hole that's in the middle of the gear. Then we're going to do another circle, in this case a center and point circle, because now we've got a reference that's the exact middle, and then pull that out, and then we'll make that a diameter of, let's try it, 10 millimeter hub. Okay, so that looks pretty good. We'll click OK, and then we'll make this 10 millimeter thick hub. And that is looking about what we want, so we click OK. And that's a pretty good looking gear to go ahead and bring into our 3D printing software. And so for making the STL file, we do File, Save As, Save a Copy, and then under the type, we look for the STL type. Which is right here under stereolithography, and then click OK, and then that creates our STL file that we can bring into our 3D print software. Here's a second way to get a gear shape, and that's to go to a catalog that has gears and import a CAD file straight from the catalog. So here's the McMaster car. We've gone to the gear section, so we'll do metal gears. Well, let's see, we'll do gears, and then in this case we'll take the inch measurement, and in this case let's look to see what we have for shafts that are 1/8 inch, and then we'll do know, let's see, a number of teeth, 24. And we'll do a gear with a plain round bore. So here's one that happens to be made out of brass, although it doesn't matter, and it's got a 1/8" face width and a 1/8" shaft. So if you click on this part number, and under product detail, it gives you an option for CAD files. So there's a number of different options, and you can export a 2D DXF here, but we're going to do the 3D IGES file and then download that. Okay, I've moved that IGES file to my working directory, and we'll click Open and then look for IGES files. IGES is an industry standard for converting CAD files. And there's our IGES file, so I'll click and import as a part, and then click OK. And then we've got that part right here in Creo, and it's just a single part, so it's not a bunch of components, but you can go ahead and add things to it, you can drill holes in it, or you can take it straight from here into a 3D print file. So again, save as, save a copy, and then style, stereolithography, okay, and that creates a file that's ready to take over to your 3D printer. So there's a couple of ways of creating gear shapes and bringing them up into Creo, making any modifications in Creo that you want, and then exporting for your 3D print machine.